Hi students, we are going to talk about whole numbers and how we can use models to help students learn how to record whole numbers that are larger than single digits. So when we talk about symbolic representation, remember the symbols are the numerals. So students have to learn how to write the numerals, and that's not always easy. If you've worked with small children before, you realize that they often struggle with writing these because of their fine motor skills. They sometimes write them backwards, upside down, that kind of thing also. So we have 10 symbols for what we call the Hindu Arabic number system. That's the number system that we use. And our symbols are 0 through 9. And if we only use these symbols one at a time, we can only represent cardinality of up to 9 objects. Remember, cardinality is the how many-ness. If we want to go above 9 objects, then we have to start relying on place value. And so if I write a number like 10, that means 10 objects. And I know you know what 10 objects means. But for a student, this is just a combination of 2 of the symbols that they have previously learned. If I write 2, 3, 5, that's a whole lot of objects, 235 objects. So students have to begin to learn, why does that mean so many objects when I'm just using a 2, a 3, and a 5, which you could look at and total up and say, hey, we're talking about 10 items. So in terms of modeling numbers, one model is a unitary model, and that means that you're counting by ones, not having any grouping at all. So if I wanted to represent, sorry guys, struggling with the technology a little bit here. So if I wanted to represent 116 with a unitary model, I would need 116 objects. In this case, they're little cubes. I would want you to look at your textbook. You were assigned some reading there, and they talk about other things that you could use rather than these cubes that you buy through an educational supply source. Bundles of sticks like coffee stirrers, counters and cups like beans and Dixie cups and that kind of thing. Anyway, this is a unitary model for representing 116 objects. So representing 116 objects this way does not help students learn about place value. It's where we begin, but it doesn't help students learn about place value. So using what we call base 10 models, okay, so we're talking here about set models, unitary models, and now base 10 models. We can use bundles of sticks. Again, I refer you to your textbook. Counters and cups. Again, I refer you to your textbook. And what we typically use in the classroom once we've graduated from these more rudimentary models is what we call base 10 blocks. And they come in ready-made pieces like this. And base 10 blocks are pretty fun because you use them a lot in the elementary classrooms, and students start kind of having pet names for them. So a lot of different teachers have different names. This right here is the unit piece. So these are your ones. But people usually have different names for them. For some reason I use the word babies. I think that's because it's one I've heard before, so I tend to call these babies. Different teachers call them different things. You obviously could continue to just call them units. This piece here is 10. So you can see if you take 10 of the units and you put them together, you get this stick. And so teachers call these sticks. They call them longs. I tend to refer to them as longs, but we know that they're tens. Right? If you take 10 of these longs and you put them together side by side, then you have a combination of 100 of these units. So you have 100 units or 10 tens, and of course that is your hundreds. And I often refer to these as flats. I think the funniest thing I've ever heard them referred to as is pancakes, which I'm just totally not getting. I could see waffles, but pancakes don't make sense to me. Then you imagine taking 10 of these hundreds, 10 of these flats, putting them side by side, and it would turn into these blocks here. So we refer to these as blocks, and you can see it's made up of 1,000 of the ones. It would take 100 tens. It would take 10 100s to form this figure. So these are our thousands. Right? So I'm going to go to a different screen here to show you some uses of the base 10 blocks. So what I have on this screen is 116 ones. And so we're going to look at this instead in terms of how does it look in base blocks. So, and how we can use these to help students learn how to write place value correctly. So I'm going to use this gluing tool here, and I am going to take and as soon as I clicked on 10 total ones, I moved over here to the tens column. So I'll do that again. Again, as soon as I got to 10. So I'm going to pause the video for a second. I'm going to move the rest of them over. I'm sure you don't want to have to watch me do all of that. In the meantime, try to figure out just how many of these sticks am I going to form. Alright, so hopefully you realized that I would be able to form 11 sticks, or I would be able to form 11 groups of 10 here. So now my next step is to say, alright, I have 11 tens, can I make any hundreds out of these? So again, I use my tool, and I end up forming one 100. So now we look at these base pieces and we see how these match here. So this 1 here refers to I was able to form one flat, or one 100 piece. I have 1 10, and I have 6 ones from there. So I'm going to take a snapshot of this and move it over to the note sheet, so I'll hold tight. Okay, I'm back here. So we can see we can take our unitary model and we can change the form of that using base 10 pieces. And we're using essentially this 10-to-1 ratio. When I have 10 of one size of base piece, I trade them in for the next bigger size. And that's how we accomplished forming this here. And that's what our base 10 number system is all about. That's what place value is all about. The last thing I want to share with you on this note sheet right here is the chip abacus. So you should have seen how the chip abacus works in your textbook reading. So I hope you are doing, all of the reading, watching everything that I've got for you, because, the intention is to get this information across to you. And I think it takes all of those things. But a chip abacus is kind of a step from the base 10 pieces to, it's a bridge between the base 10 pieces and the symbolic representation. So a chip abacus essentially uses what we call a base 10 mat. And these columns here are for the different place values. So these are the ones. I'm writing a 1 and an S. That's not 15, that's ones. These are the tens. These are the hundreds. Again, that's an S. And these are the thousands. All right. And so what I show, it's a chip abacus. So students use chips, like poker chips. And essentially, one chip represents how many of these I have. So I have 100, I have 10, and I have 6 ones. So if I look here, the pieces are different shapes. And that's great because they represent and they show it takes 10 ones to make a 10, 10 tens to make 100. But then using the chip abacus here, we're literally counting how many hundreds, how many tens, how many ones. And then this directly relates to how do I write that number correctly using symbolic representation. Well, in the hundreds column, I have 1. In the tens column, I have 1. In the ones column, I have 6. All right, so I'm going to go back to this screen for just a minute. And the reason I want to do that is, to kind of show what's important to students in going backwards. So this can be kind of confusing to students sometimes as a representation for a number. Because remember, when they first learned to count, they were counting objects. So you can kind of imagine a student saying, all right, one-to-one correspondence, 1, 2, 3, 4, 5, 6, 7, 8, which is nowhere near 116. So it's really important that students can go backwards and say, hey, if I take this hundreds and I break it up, what do I get? And I get 10 tens. And if I take a 10 and I break it up, I get 10 ones. So now I'm breaking up all of my tens. And I wish when I clicked on them it scattered them more over there in the ones column, but it doesn't, so I just have to go with what it does. Okay. So now if I individually went back and counted up each one of these units, each one of these ones, I would have 116. You might be wondering, why in the world did I even bring up the cups and the counters? Why in the world did I bring up the bundles of straws or bundles of sticks? And the reason is because hands-on in the classroom, these objects don't actually break into pieces. So you'd have to use some kind of a virtual environment for students to be able to see them, a hundreds piece turn into 100 ones. But if you have cups, and they're filled with beans, and you want to make your point of, hey, if I've got, a hundreds, if I spill that out, that is equal to, 100 ones, and help them with the cardinality. So that's it for this screencast. I think there's been some technical difficulties through this. I hope that didn't bother you too much. I'll see you next one.